There we go.
Alright. So I had number 8. And the formula was an equals negative n squared. So first I just plugged each of the first 6 numbers into the formula, and then there's my graph. Yeah.
Any questions? He wants to sit down really quickly.
I mean, you won't lie.
Using I had number 28, and it said to graph the sequence, and the sequence that it gave me was -2, -5, -8, -11, and -14. And since there's 5 numbers in that sequence, I labeled the x-axis 1, 2, 3, 4, and 5. And since the highest number was -14, or lowest number was -14, I went down the x-axis to -14 and plotted the points. And I said it had no limit because there was no curves.
Any questions on number 28?
This game, do I leave this up here?
Yeah.
What?
What was the pattern for that?
Subtract.
How do you get the number same?
So if you look in your packet at the bottom of page 5, see if you can describe the pattern, write the next term, and write a rule for the sequence. If you haven't done so already. Oh, yeah, you don't have that. using n instead
We're
of
not
s.
letting you down. I'm gonna be with you.
Alright, so let's look at the two problems in the packet and then we'll talk about some of the patterns and the rules for a couple of the problems in the book. So it says, describe the pattern, write the next term, write a rule for the nth term, which is very similar to the directions of 15, 16, 19, 20. So the directions were very similar. So what's the pattern here? 1, 8, 27, 64. What kind of pattern would they have, Will?
Whatever position the number is in, cube it.
Yeah, so he said whatever position the number is in, we cube it. These are perfect cubes. So 1 cubed, 8 Will is really
2 cubed.
2 cubed, 27 is
3 cubed.
3 cubed, 64 is 4 cubed. So the next term, Will, would be
125.
125. So a pattern, you could say they're perfect cubes. The next term is 125. And then the last part says write the rule for the nth term. What would that rule look like?
N cubed.
Yeah. So you would start out with saying A with the little subscript n. So A sub n represents the fact that we're now solving a sequence instead of an equation. And he said it would be n cubed. So the position in the sequence represents n. If I'm in the 5th position, I plug a 5 in and I get 5 cubed, which is 125. So n represents the position that you are. You use that position to find the term by applying whatever pattern you're looking at. So the next one we have -4, -8, -12, -16. So again, the first part, describe the pattern. So what's the pattern happening with these numbers? Rebecca? Yeah, so she said subtract 4. So Rebecca, the next number would be? -20. And then the last part, did you write a rule?
Yeah.
What do you have?
-4n.
Yeah, so -4n. So just see if it works. So if, for the first one, you would have -4 times 1. Well, yeah, that makes -4. The second one, you should be able to plug in a 2 because you're finding the position, or you're plugging the position in to calculate the term. Well, that makes -8. And we would plug in a 3, and that gives us the third value of -12, and so on. If I plug a 5 in, I get -20. So let's take a peek at a couple of those problems from your homework. Some of them are harder than others. So they're not always going to be kind of as easily seen, understood. And let's look at number 16. So number 16, we have 1, 2, 4, 8. Again, the directions want you to describe the pattern, write the next term, and then write a rule for the sequence. So Julian, what did you think for the pattern here? 1, 2, 4, 8. What are you doing to get from one number to the next?
You're doubling the last number.
Okay, so he said doubling the last number. What's another word we could use? Mackenzie? Yeah, they mean the same thing. So doubling, multiplying by 2, they mean exactly the same thing. So double the last number, multiply by 2 to get to the next number. Mackenzie, what would the 5th term be then? 16. Okay, so multiplying by 2, doubling the last number, so therefore we get 16 because you're doubling 8. What would the rule be for the sequence? Julian?
2 times n minus 1.
He said 2 and then to the n minus 1, or did you say 2 times 2 times n minus 1, like that?
No, there's like parentheses around the n minus
Okay, parentheses like that. Okay, so when you're looking at these problems, you gotta write something down with an n, and then you have to test to see does it work. So if you plug a 1 in here, I would get 1 minus 1 because 1 represents my first term. So I should be able to calculate the 1 from that first term plugging in a 1. Well, that gets me 2 times 0, and unfortunately that would start us off with a 0. So if I plug a 2 in, it works for the second term, but it doesn't quite work for the first term. So he's on the right track, and he has something written down, and like you just have to try and write something down. So we're definitely on the right track, but just not quite there yet. Emma. So she said, what if it's 2n minus 1 written as an exponent, which is what I thought Julian initially said. So again, try it. Let's see what happens. So if you plug a 1 in, because I want to get this first term. So I would have 2 to the 1 minus 1. Emma, what is 2 to the 1 minus 1? Yeah, because 2 to the 0 makes 1. Okay, try it a second time. My second position would be 2 to the 2 minus 1, which is 2 to the first, and that gives me 2. Ooh. I'm going to try it one more time just to make sure that this works. So this is my third term, so I plug in a 3. Well, now that's 2 squared, and 2 squared is 4. So it actually gets written as a power, because all of those can kind of be thought of as powers of 2. So 8 is 2 cubed. The next one, 16, is 2 to the 4th. I would then have 32, which is 2 to the 5th. They're actually all powers of 2. So I think the next one on there was a fractional one. Number 19. Let's look at number 19. 19, you have 2 over 3. Can't remember what the other ones were, but 6, 9, 12. So the first one, describe the pattern. Julian?
So you're adding 3 to the denominator.
So he said the denominator is adding 3. What else could you say for the pattern besides adding 3 to the denominator? How else could you kind of word that? Thanks. Maggie, what else could you say about the pattern for 19? Yeah, you could also say multiply by 1/3. They mean the same thing. So there are a couple different ways you can describe the pattern. Adding 3 to the denominator, or you're multiplying by 1/3. Because the top is staying 1, the bottom, you're multiplying by the 3, except I think for this one here, it doesn't quite work. So it works for part of them, but then that other one, is this 12 or is this 27? It is a 12. So it doesn't quite work once you get to the next couple of numbers. So we can keep it as adding 3 to the denominator. We'll kind of keep it there for now. So the next term would be what? Julian?
2 over 15.
Right, 2 over 15. So now we have to try and come up with a pattern. A pattern has to involve an n in it. What do you notice about all the fractions? Julia?
They have a 2 as a numerator.
They have a 2 as a numerator. So that has to have a 2 as a numerator for my pattern, because that 2 is consistent. It's 2 every single time. And then we have to try and think of, like, how can we write the bottom part? So we have a number for the numerator, but we need to come up with a number for the denominator. Julia, did you have anything written for the denominator?
3n.
So she said 3n. So again, write something and then try and see if it works. So I know I have 2 on the top, but focusing on the bottom, if I plug a 1 in, 3 times 1 is 3. If I plug a 2 in for the second position, 3 times 2 is 6. If I plug a 3 in for the third position, 3 times 3 is 9. A 4, 3 times 4 is 12. A 5, 3 times 5 is 15. So this would be my rule for the next term. So focusing on what's going on at the top, what's going on in the bottom of the fraction. Yes, they are a little more challenging, and tomorrow we'll figure out for some of them, there is a special pattern that we can kind of think about and follow, but not for all of them. So like this one here, you wouldn't really have a pattern. You're just gonna have to visually, logically think about what's going on and try something. You've gotta write something down. So in your packet, we've got just a couple other examples to look at. I think there's two more definitions, and then I think those definitions have 4 examples with them. There are 2 main types of sequences, and those 2 main types have a specific pattern that they follow. The first one is called an arithmetic sequence, not arithmetic. So arithmetic is a noun, it's a type of math. Arithmetic is an adjective, and it describes the type of sequence. So when it's an adjective, it gets pronounced a little differently. So it's an arithmetic sequence. The other sequence we have is a geometric sequence. There are 2 types of sequences. If it doesn't fall into one of those categories, then it's just a random sequence. Yes, it has a pattern, because it's a list of numbers with some type of pattern, but it doesn't get a special name. So 2 main types of sequences. The other ones just fall into the neither category. They're not one of these, they're still a sequence. So if it's an arithmetic sequence, you either add or subtract the same value to get to the next term. So every single time you're adding or subtracting that same number to find the next term. So if you say you're adding 4 to get to the next value, you have to be adding 4 every single time. So with the numbers they give you in the sequence, and then to continue the pattern. So if I was adding 4, I could have 4, 8, 12, 16, 20. That would be an example of an arithmetic sequence. Every single time you're adding 4 to get to the next value. The other sequence is called geometric. Geometric is found when you're multiplying Okay, apparently I can't spell multiply today. Did I spell it right? I don't know, Y and I look weird to me today. So multiplying by the same value to find the next term. Not divide, because division is really multiplying by the reciprocal. So if your mind is saying divide by 2, you have to flip it and say multiply by 1/2. So we will never say you're dividing by something. We'll always think of it as what are you multiplying by? And really you could argue the same thing with addition, because addition is really just adding a negative number. So you can kind of argue that same case. So an example of a sequence that would be multiplying by the same number, I could be multiplying by 3 and have 3, 9, 27, not 54, 81, and then continuing the pattern. Or if I was using 1/2, maybe I would start with 100, cut it in half and get 50, cut it in half, get 25, cut it in half, get 25 halves, and I could continue the pattern on as well. So I'm multiplying by 3, or I'm multiplying by 1/2. So when you're multiplying by a fraction, your numbers are going to get smaller. So yes, your mind might be saying divide, but kind of switch that and think of what are you multiplying by. So there are 4 problems at the bottom for you to just identify if it's arithmetic, adding or subtracting, or geometric, multiplying. And then it says explain your choice. The option could be neither as well, because maybe it's not one of those. So just kind of look at those 4 and see if you can figure out, are you adding or subtracting the same number to get to the next term? Or are you multiplying by the same number to get to the next term? And again, it has to be the same number each time. same number when it's needed. I always wonder why they choose to mow right at 7:45 in front of my room. And they could do it at 2 o'clock. It just doesn't work with their schedule, I guess. Mackenzie Myers, what did you say for number 1? Why?
Is there definitely a pattern, or that they're not adding the same number?
Okay, so what are you adding then? Like, what are you doing to get to the next one?
I'm not sure.
There is a pattern. Rebecca, did you find some type of pattern? There has to be some kind of pattern. So it is neither, but you are adding something to get to the next number. What do you add to 2 to get to 5? 3, okay, so 2 plus 3 makes 5. What do you add to 5 to get to 9? 4. What do you add to 9 to get to 17? 8. Doesn't look like there's any pattern. Did anybody see a pattern? So it's a random list of numbers. But you can write anything, there is no pattern, you're not adding the same thing each time. Just a random list of numbers up here. How about the next one? 3, 6, 12, 24. Will, what do you think for number 3? Or I'm going horizontally. Will, can you go horizontal for me? What do you think of number 3?
Multiply by 2.
Yeah.
So it's geometric.
So multiply by 2, therefore it's geometric. All right, Holly, how about 6, 1, negative 4, negative 9?
It's arithmetic because you subtract 5.
Yeah, nice job. So arithmetic, and I know that's weird kind of saying it that way. And she said you subtract 5. I know there is a name for words where you pronounce them differently with their verb versus an adjective. I just don't remember what that name is. It's like a specific type of word. No English people in here that know all those terms. Call my husband, phone a friend. I could ask him. The last one here is also a little tricky, but it is one of the options. Odette?
Geometric.
Why do you say geometric? Because it still looks like they should be random.
Multiply by 2 thirds.
So she said multiply by 2/3. How'd you figure that out?
Because when you look at 4, it's 2/3 of 6, and then it goes into thirds later. So
Okay.
2/3 is 2/3 of 4.
Yeah. So I think sometimes looking at the fractions might be a little easier. What would you do to get from 8 to 16? Well, I would multiply the top by 2. To get from 3 to 9, I could multiply the bottom by 3. So if you can think of a pattern, then try it with the other numbers. 6 times 2/3 is 4. 4 times 2/3, so 4 times 2 is 8, and then I have that thirds. So look at the fraction part, the back part, see if you can create a pattern, then test it with the other two. So I have a worksheet for you. It's a front and a back. The front is kind of a review of yesterday. The back has problems that you were just saying if they're arithmetic or geometric and kind of explaining why. You're not doing all of the back or all of the front, so make sure you're looking at the side there. So the front part where it says practice A, you're doing 1 to 17, and then there's a little word problem, number 24, with amoebas. And then on the back, it's just a whole bunch of sequences, but you're just doing the first 12 of those sequences. Did I give you enough? Yes. So again, make sure you're marking down the problems that you're doing. They're on the board next to Brock over there. It's the same as on the assignment sheet as well. Yes, they're listed on the assignment sheet as well. And then I'll send the answer key right now. I'll send it through Remind posted to Google Classroom. And again, the front of it says practice A, 1 through 17 and 24, the word problem at the bottom. The hardest part is going to be writing the rule for the sequence. That's going to be the tricky part. Just do the best that you can. Try and write something down and test it. And then on the back is just a whole bunch of sequences like the 4 here. You're deciding if it's arithmetic, geometric, or neither. And it might be neither. Make sure you're writing a reason why. So make sure you're saying it's arithmetic because you're adding this number every time. So you still have 12, 13 minutes. Show a little bit